A tank has two water pumps, alpha, beta, and one drain. Alpha can fill the whole tank in. So alpha can fill the whole tank in X hours. Beta can fill it in Y hours, and gamma can drain. It's a drain and can drain the whole thing in Z hours. Of course, we're given that Z is greater than X. What is the relevance of this? Why is Z given to be greater than X? Because if Z is less, if it's, if it takes a very short time for the drain to drain out, less than what the pump is taking to put in the water, then the tank will never fill up, right? So basically they're telling us that the drain is, it takes more time to drain out as compared to the pumps. When the tank was empty, pumps, alpha and beta started pumping water in the tank and the drain was draining. When finally the tank is full, which of the following represents the amount of water in terms of the fraction? So all three are working together is what is given to us, right? Alpha, beta, and gamma all are working together. And the question is, when finally the tank is full, which of the following represents the amount of work in terms of fraction of the tank, which pump alpha pumped into the tank? So they are saying that all three of them work together, and when the tank was full, then how much work had alpha done? Yeah. All right. Now, when was the tank full? We need to find that out, right? Okay, let's try and use our variables first of all. So A takes X hours, B takes Y hours working alone, and gamma takes Z hours working alone. Yeah. Rate of A, I know rates are additive. We just discussed it in our question 1, remember? Yeah. So what is the total rate of all three when all three are working together? What do I get? I get 1 upon X plus 1 upon Y. It's a drain, so the rate of work is negative, minus 1 upon Z, because their work is getting added, whereas this is subtracting out the work from here, right? It is doing the negative work over here, right? Okay, now let me add. Rates are additive. I'm adding up all the rates and I'm going to get the total effective rate of all three of them working together. So I get X, Y, Z. I get YZ plus XZ minus XY. Simple. All right. Now this, remember, is the rate at which all three of them are working together. So the time taken by them to fill the tank, it will just be the inverse because they are filling one complete tank. So then the time is inverse of the rate. So my time taken will be XYZ upon YZ plus XZ minus XY. Is it okay? All right. Now we need to know, what was the work done by tank alpha? Yeah. So basically, how much was the work done? I know that my work done is equal to time for which that work was done into the rate at which the work is done. So this is the time for which this one is the time for which my alpha did the work. And at what rate? I know that rate of alpha is 1 by x, right? Because alpha alone takes x hours, so rate of alpha is 1 by x, which means that how much work was done by alpha? It is yz upon this particular thing. So what do I get? Yz upon this, which is my, where do I have yz? Yeah, here, x, right, exactly. So then this is my answer. This is what I get. Makes sense? Yeah. Was it very hard to do with the variables? When you have so many variables, look at the options, they're kind of very similar to each other, right? When you have something like this, it is preferable to go the variables way in case the logic is clear and simple, in case you're being able to understand. Why? Because now the moment we start plugging in values, it is going to become a little harder to track all the values. X is this, Y is this, Z is this, etc. All right, and we cannot take very simple values for a couple of reasons. I can't take those ones, the ones that I love so much, I can't take them. Why? One, I know that Z is greater than X, so I can't take X is 1, Y is 1, Z is 1. Of course, it will not work. Another thing, note that the options are very similar to each other. So do you see, for example, here I have, yz, xz, and minus xy. Here also I have the same thing. Here I have the same thing, but the numerator, anyway, that will change the number. That's fine. But here I have a yz, here I have an xyz, which means if I take one as a value, then both of them are going to give me very similar answers, right? So taking them as one may not be appropriate. Then it is going to give me similar answers, and with three variables I have so much to track. If I have to do it twice, that's going to be even more time, right? So if I must take values, then what values will I take? I'll take, let's say x is equal to 2, let's say y is equal to 4, and let's say z is equal to 8. Values which are not going to make my calculation very complicated. I'm not going to take x is 2 and y is 3 and z is 4 or something. Why? Because when I then have to take the LCM, when I have to add, there are like 2 is a factor, 3 is a factor, it just becomes so much harder, right? So I want everything to be distinct, but I still want my calculation to be easier, right? Okay, so now if I've taken that, alpha takes, all right. Yeah, so I'll talk about that later. Let's just finish this question first. Okay, so now x is 2. I've taken x takes 2 hours, y takes 4 hours, and z takes 8 hours to completely fill the tank alone. Yeah. When all of them are working together, their combined rate, effective rate, is sum of their individual rates. Rate of x is what? 1 by 2. Rate of y is what? 1 by 4. I mean, alpha, beta, same thing. Yeah? And rate of z is what? Minus 1 by 8. Why? Because negative work is taking place. Now my calculation is relatively easier. I'll say I'm multiplying this by 4, so I get 8. I'm multiplying this by 2, so I get 8. I get 6 and minus 1, which is 5. So I get 5 by 8 over here. This is the reason why I took 2, 4, and 8, because my calculation is very simple, right? I'm just taking multiples of each other, though they are distinct values. So when I plug in the options, I'll get all distinct values. Yeah. Okay, so this is my combined rate of all of them. This is 5 by 8. And so then what is the time taken? So then time is going to be just inverse of that. So time taken will be 8 upon 5. Yeah. All right. Now, um, 8 upon 5 is the time taken for all of them to fill the tank together. This is the time for which alpha was working. Yeah. But I need to know the work done by alpha. Work done is equal to what? Rate into time. Yeah, here, this is your question, Ashna. Yeah. Work is equal to rate into time. Yeah. I know the time for which alpha was working was what? 8 by 5 hours. I want to know how much work did alpha do. So I'm saying this time is 8 by 5 hours. What is the rate at which alpha was working for these many hours? Alpha was working for 1 by 2, right? This is the rate. X, alpha, x, whatever, takes 2 hours to fill the tank independently. That means the rate of x, the rate of alpha, is 1 upon 2. 1 half of the tank per hour is the rate of x. So what is the rate? That is half. So when I multiply this, I get work done by alpha is 4 by 5. Right? Now I'm going to plug in my values of 2, 4, and 8 in all the options, and I'll get the answer as 4 by 5. And only B is going to give that answer to me. Yeah. Look, when I plug in the values, do you see that there is a lot more work I ended up doing? Perhaps using, this was a little easier. When I have too many variables that I have to handle, it does become a bit of a problem. Yeah. But then what if the relation is not clear to them, if I don't know how to move ahead, then I might as well get my answer at least by plugging in values. Yeah. And when the options are all just so close together, where I know that, if I take them to be very similar, if I take the same values for everyone, then all the options are going to come out to be the same, then of course I can't do that. I have to take them distinct values and, slightly a little one step more complicated than 0 or 1. Yeah, just in this case. Is this okay? Yeah, so is your question resolved? Do you understand why we multiplied this by 1 by x? Because we have to multiply it by the rate. Right? When work done, we are looking for alpha's work done. Work done is what? Rate into time. So alpha's rate is half into the time taken the time for which alpha was working was 8 by 5 hours. So we did the same thing with the variables also. Okay, I don't really know what have you written over here. 1 by x into time. Yes. All the rate into time. All the rate. So so 1 by x into time, this is the time for which alpha was working. This entire thing, it gives me the time. All three of them were working together till the time they filled the tank. So this was the rate at which all three of them were working. So the time for which all three of them were working is this. So then alpha was also working for this time only, right? And beta was also working for this time span, whatever this time was, this 8 by 5 hours. So alpha worked for 8 by 5 hours, beta worked for 8 by 5 hours, and gamma worked for 8 by 5 hours. And how much work did alpha do in that time, in that 8 by 5 hours? Half into 8 by 5, because the rate of alpha is half. So that is why 1 by x into the time.